Yeah, nice one. Okay, so starting where we left off on Tuesday night. Okay, question 9. Just checking that. Yeah, we did that one, didn't we? Okay, question 9 is a vector question. All right. So vectors are a way of describing a journey. So if you think about it just as how we get from one place to another, okay, you can describe that in a couple of different ways. So we're starting at H. Now H is just a point in space. All right, it could be a point anywhere. If you want to think about it, it could be a town. Okay, it could be Helensburgh. All right, and you're wanting to travel to another point in space. Okay, in this case, it's labelled F. All right, that could be Falkirk. All right, so we're going from Helensburgh to Falkirk, and we want to describe that journey. All right, that's all we're looking to do. Now, H to F, we could go directly H to F. All right, but only if we know enough information to do that. But it's asking us to describe it in a slightly different way. All right, so we could go directly H to F. All right, we could go direct, that's straight motorway, both Helensburgh, Falkirk, no bother at all. Okay, but we've not got enough information to do that. I want us to express it in terms of A and B. Now, A and B could just be different roads to get to those two towns. All right, between them. So instead of going the motorway that would take us directly there, we need to go down a couple of side roads, A roads or whatever. All right, so it's just a different way of doing that path. All right, the same journey. All right, so describing or expressing HF. All right, getting it to F from H in terms of A and B. Well, we need to follow the path of A and B. Now, A and B again are just labels that have been put on that journey. Now, what's important with vectors is there's going to be a direction involved as well. Okay, so we're going from Helensburgh to Falkirk, we're not going from Falkirk to Helensburgh. So that's where this wee arrow above the HF comes into play. Now, A and B are just different ways of labelling a vector. So that A, okay, is given a direction in the middle of that line, and a wee arrow pointing upwards in that direction. So A is sort of travelling from G to H, I suppose. So G could be Glasgow. Okay, so we're going Helensburgh via Glasgow to F. Okay, that's what we want to explain it. That's just an A road. And B, and it's going in that direction, just another road. All right, so that's a path we could take. Okay, so we're explaining or we're expressing the trip from H to F using those two roads. Now the direction is important, all right? So A is the vector that's going from G to H, it's pointing up and to the right, okay? Now to get from H to F, we need to go the opposite direction. All right, to get from H to F, we need to go opposing A. All right, or the way we write that, B, negative A. We're going against the flow. Okay, so we're going from H to G, and then we're going from G, G to F. So we can take that green path, and that second part of that journey, well, B is going from G to F anyway, so it's positive B. That is literally the answer. All right, that's 2 marks. Okay, if you want to put it, it's not necessary, but HF equals that. Or that's perfectly acceptable. Sometimes it's easier and a wee bit neater to write it with the negative coming second, all right, B minus A. So it's all about following a path and what you're getting asked to describe. All right. So the lettering system that they use and the arrows that they use is important to tell you direction. So if you're following a path, to get from H to G, you need to go against the grain, against the way the arrow for A is pointing, vector A is pointing. Okay, vectors are sometimes hard to get a grasp of, so hard to imagine. All right, but put it in the simplest form. We can go directly from H to F, or we can go in a wee roundabout route. How do we describe that route? Okay. Express Hn in terms of A and B. Now, we're going to use part of this answer, HF. So we know that HF is B minus A. Okay, so I'm going to write that. Okay, so I'm going to have that sitting there. Now, when we look at it up here, so we've now got Hn equals 2NF. Okay, so let's break that down a wee bit. Well, we've got H to N, which is a length. We've also got from position N to F, and that is also a length. So 2 of those blue lengths equals 1 of those green lengths. Does that make sense? So 2 of NFs, so 2 journeys from, I'm going to say Norfolk to Falkirk, but that doesn't make sense. Newton Mearns, does that make sense? Not really. 2 journeys from Newton Mearns to Falkirk is the same as doing a journey from Helensfoot to Newton Mearns. All right, so if you express it like that, it's a distance. So Hn is just twice as far as NF. Okay, so that's what that's telling me there. GH represents vector A, GF represents vector B, so that's the same information we've got. Now we want to express Hn in terms of A and B. Now we can express Hn just going directly H to N, or we can express it by going H to G, okay, which is known as vector A, or negative A. And then across like that. Or we could express it by minus A plus B, okay, plus the distance NF. How to best explain this? Okay, so H to N is 2NF. Now we know HF is B minus A, so we know that full distance is B minus A. Okay, that red line. So that essentially could be broken into 3 of the distances NFs, all right? So that distance is the same distance as NF. And that distance is the same as distance NF. Okay, so essentially Hn is 2/3 of that full distance. All right, so that's what it's looking for you to understand. Is it's hard to explain and say it outright, but NF, if you do that 3 times, okay, if you made that journey 3 times, you're doing the equivalent of the journey HF. So Hn is equal to 2/3 of B minus A. Now, I've spent a lot of time explaining that and trying to sort of break that down into different pieces. But it's one of those you just essentially have to visualize. Right, we can take that information that NF is 1/3 of that whole thing. No, I think that's the answer.
You always start like something.
No. It'll be different reference and stuff like that. So it'll tell you. Well, it shows you. So H to N. Just that question about the directions. So if you're given H, N, all right, and then an arrow pointing that way, that means you're starting at H and you're going to N. Okay, so that's why you're given at the top there in the arrow. That tells me that you're starting at G and you're going in that direction. You're going up and to the right. All right.
Daniel, can I ask a wee quick question?
Go for it.
Am I right in understanding this that vectors ignore distance then? Because when you add up the distance that would be visualized in this between A and B, HN is not 2/3 of that distance, because the distance that you go from H to G, then G to F, is substantially longer than what you would get from going from H to F.
So the point of it is you end up in the same place. So yes, you ignore the
distance.
total distance travelled, and it focuses on essentially like as the crow flies.
Right, okay. So B minus A is essentially the same as HF.
Yes.
Although if you actually visualize it as an actual thing, then it isn't, but
So
we have to work it as if it is.
So it's not the same distance, but you're ending up in the same place, and that's the important part.
Right, vectors ignore distance, no problem.
So that's where I'm saying, yeah.
So vectors account for motion and direction, but they don't account for distance.
Yeah.
Right, okay, that's fine, thank you.
We literally make it as simple as Glasgow to Edinburgh. All right. We can say 40 miles. All right. We can describe that as GTE. All right. We're going in that direction. We could also have a journey that goes up to what's north, Perth, and down to Hoyt, and then up to Edinburgh. They end up in the same place. The distance is totally different. Okay. But as a way of describing to get from Glasgow to Edinburgh, it's still a valid description of a journey.
Mm-hmm.
Likewise here. H to F isn't the same distance as HG, GF, or A, well, minus AB. Okay, it's not, but it's the data that we've got. We've got information about vector A and vector B that we can use to determine where F is. We might not have everything, all we need to know about the direct HF. We might have more data about H to G and then G to F that allows us to figure out where F is. So it's just a point. So those different points that are labelled are just different positions in space. Yeah, yeah, yep. So that's you taking the fact that H to N, to NFs. So NF, NF, NF. It's a
So,
hard, vectors
ca-
are difficult to visualize. I won't say anything else.
I I think the thing that's kind of throwing me a wee bit is having to assume that all distances are equal when you're looking at it. And you only operate by the numbers, because if you try and visualize it as an actual 2D sort of triangle like thing that we're looking at here on the screen, it's difficult not to take distance out of the thinking, out of the visualizing for it, you know.
Yeah.
Because if you tell me that the distance h to n is 2/3 of what it is to travel h to g, then g to f, I'd be like, you're mad. Because when you add them all together, it can't work out the same way. Because if you add on all those, it's not the same distance. So I can visualize it, but it's off-putting having that diagram there. It's easier to do it without the diagram, because then you can assume the distances are the same, and it doesn't confuse you in that way. You know?
So I suppose with vectors, the important thing is the direction of it. It's not necessarily the distance you're traveling or essentially the effort you're putting in maybe to get from one place to another. It's where you
Yeah.
start and where you finish. And
Okay,
you can do
thank
that
you.
various directions.
Cheers. No bother.
All right, Rob. Okay. Back to something a wee bit easier to visualize because it's right in front of us. All right, sector circle shown, diagram, calculate the area of the sector. Diameter 15, angle at centre 152. Okay, so it's a sector question, straightforward sector question. Okay, where we take a proportion of a full circle. So an area of a circle, area of a full circle, pi r squared. But we're only taking a proportion of that. We're only taking a percentage of the full circle. So its area is equal, area of the sector is equal to the angle, which I draw as a wee circle with a line through it, all right, over 360. 360 is a full circle, here 360 degrees. So what we're finding out there is the ratio of the angle divided by the full circle. Okay, so the proportion of what the sector is actually showing, multiplied by pi r squared. Okay, that's our sort of formula for area of sector. Okay, the diameter is diameter is 15, so radius is 7.5. Okay, and that's 7.5, let's just get put into our formula. Okay. So I'm just going to move over to the left here. Sector area is equal to 152 over 360 multiplied by pi. Remember, pi is just a constant, it's just a button in a calculator. 7.5 squared. Okay. And I don't have a calculator. So area you're getting 74.61. That's in centimeters square. Okay, hopefully that's nice and straightforward. Okay, there's no tricks there. Nothing to throw you. Any questions on that one? Good. Graph question. Okay, you're given an equation, x plus 1, x minus 5. Okay, now essentially that is a factorized trinomial. Okay, so we could break up those brackets and we'd get a trinomial out of it. We've already created the factors for you, so the factors are where they cut the x-axis. So remember, if we equated that to 0, we'd get x equals -1 and x is equal to 5. Okay, but they're already shown in the graph. We're given that information anyway. Okay, -1, 5. Now let's see what it's actually asking you. So find the coordinates of C where it cuts the y-axis. So it cuts the y-axis here. So we're looking for that coordinate. Now, when does that happen? Well, that happens when x is equal to 0. So it cuts the y-axis when x is equal to 0. So your coordinate is going to be 0 something. So we substitute x is equal to 0 into our equation, and it will spit out an answer for us. Y equals x plus 1, x minus 5. All we do is 0 plus 1, 0 minus 5. So it's 1 minus 5. And remember, when brackets are beside each other, that's just multiplying them. It's minus 5. So the coordinate now you're showing a graphic of that. So does that actually make sense? Well, yes, it's below the x-axis, it's below the line, so you're expecting a negative y, and x will be 0. So that makes complete sense. All right, so that coordinate is 0 minus 5. So you're just substituting x equals 0 into that, and then solving. All right, similar question. All right, find the coordinates of the turning point. Now the turning point is where it hits its minimum, or if it was the other way around, where it hits its maximum. Okay, so the turning point's here. Now we could do that by completing the square. Okay, so by completing the square, we can pull out the turning point from that, but we don't have to do that. Where that turning point exists is right in the middle of the two roots. All right. So if we work out where the center of those two roots, okay, half the distance essentially from -1 to 5. Okay, if we work out what that value of x is, then we can just substitute it into that equation. We'll get the value of y, and that's us. All right. So the total distance from or between roots is equal to 6. All right, and it's not 6 centimeters, it's just 6 units. All right, so -1 to 0, and then 0 to 5. There's 6 positions that's doing. All right, so half of that equals 3 away from each. All right, so 3 to the right from -1, or 3 to the left of 5. I'm just going to put the word units there. Just to show that it's a distance, all right? There's no units, but it's 3 jumps, right? So half that distance. Now that's not x equals 3, that's 3 units away from -1. All right, so -1 to 0, 0 to 1, and 1 to 2. So when x equals 2, we're right in the middle. Because we're 3 away from -1, we're 3 away from 5. So the value of x will be 2. All right, x equals 2. Now you don't need to write all that out. I'm just writing that for your understanding. You look at that and you go, well, to get from -1 to 5 is 6 jumps. All right, -1 to 0, 0 to 5. There's 6 spaces between that. What's the middle of that? Well, x will equal 2. All right, so you can just go straight there. You don't get any marks for writing all that rubbish out. All right, x equals 2 is enough. And you just substitute that into your y equals x plus 1, x minus 5, right? 2 plus 1, 2 minus 5, 2, oh, sorry, 2 plus 1 is 2, 3, 2 minus 5 is minus 3, so minus 9. So the coordinate, that turning point, is 2 minus 9. Does everyone see what my logic was, or what my step by step was? Now, you've also, by doing that, you've also answered the next question. The axis of symmetry is just x equals 2. Essentially, it's where the turning point is, the x value of your turning point. All right, so the x value of your turning point. That's the answer to that. Okay. Calculate the volume of the sphere. Volume of a sphere. The sphere is the circular bit up the top there. So sphere you get given in the formula sheet. Volume is 4/3 pi r cubed. Okay, that should be a 4/3. Right. Got a diameter of 2.4. So the radius will equal 2.4/2 equal 1.2. Okay, so volume of the sphere, putting that in, 4/3 multiplied by pi multiplied by 1.2 cubed. And it's just a case of putting that in your calculator. It's 7.24. And remember, the units will be cubed, centimeters cubed. All right, so if it's a 3D shape, remember it's cubed. All right, there's a wee 3 above it. That is worth 2 marks.
See, that one, is that trying to trick you a wee bit because it's like got the bit at the bottom?
No? Sorry, we'll come to that. So we'll,
Alright, okay.
I'm assuming we'll have to do something with that in the next part.
Yeah.
So you'll need to work out H in the next part. But it's not that tricky yet. But probably will in the last part of the question. Total volume of the stopper is 20.5 centimetres. If the cone has a radius of 1.4, calculate the height of the cone. Okay, so the total volume of that stopper, the sphere plus the cone, is 20.5. So volume of the sphere plus volume of the cone equal to the total volume. So we know the total volume is 20.5. So the volume of the sphere we got as 7.24. 7.24. Yep, sorry, just checking 7.24. Plus the volume of the cone would give us 20.5. So we will just want the volume of the cone. We take the 7.24 over to our side. Comes a minus. Now give us the volume of the cone to be 13.26 centimetres cubed. 1 mark. Now we need to establish the height h. Now the height is going to be part of our formula. So the volume of a cone, again, we've given this in the formula sheet. Okay, and we're given it in the format of volume of a cone is 1/3 pi r squared h. We want to find h. Now we've got the volume, 13.26. We know what pi is, and we've given r in the question. Yep. So we need to rearrange it to find h. We need to take everything across. Now there's always this type of question where you need to rearrange one of these formulas. Okay. Get good at it. Flipping it around is probably the easiest way. It just puts h on the left hand side. We want h on the left hand side. It makes it a wee bit neater. So I'm not doing anything with the formula, just switching it round. And then I'll move everything. So if I move the 1/3, I'm moving the 3 across to the other side. The 3 is a divide on the left hand side, it becomes a multiple. The pi is a multiple on the left hand side, so it becomes a divide. And the r squared, I'm moving that whole r squared over, so that becomes a divide. So h would equal 3v over pi r squared. Okay, is everyone comfortable with that transposition? Then I'm just putting in the numbers. H equals 3 times volume, which we worked out to be 13.26, divided by pi times 1.4 squared. All right, when you're putting this in your calculator, just put the top into brackets and the bottom into brackets. All right, just keeps that a wee bit tidier, does it in the right order. You should get the value h being 6.46 centimetres. Okay, so try that in your calculator. Just make sure you're comfortable with it. Make sure you're comfortable with that transposition. Just brackets. Just ensures that it doesn't get over. So that whole thing, divided by that whole thing. You did it like that, it's not equal to 6, make it divided by half first. You might just do it this end, but it's not a different order, so use brackets. Like I've done there, just to make sure when you put it in the calculator, or when you've got a fraction like that, there's a fraction button on the calculator. So we did it without brackets, we never know. Alright, but just not use brackets. Trig identities. Okay. Trig identities. Comfortably the worst answered question in any paper. Okay. That's because we need to remember two identities. The two identities we need to remember. Okay. Are as follows. Now this is a weird one. Trig identity sort of stands as its own question. They can't really combine it with anything. And they can't really do a huge amount with it, but it's so horrible to look at. So our first trig identity is sine squared plus cos squared. Sorry, sine squared x plus cos squared x equals 1. Our second trig identity is tan A equals sine A over cos A. Now you, in the question, have to use one or the other, all right? So you either use the first trig identity or the second one, all right? And what it's looking for you to do is substitute in part of it, okay, in place of that formula, okay, and then simplify. But you might have to look for a slightly different order of that trig identity. For instance, that first one I can rearrange to have as cos squared x equals 1 minus sine squared x. All right, that's still the same trig identity. Okay. Or sine squared x equals 1 minus cos squared x. Okay, that's me just rearranging that same trig identity, that first trig identity. Likewise, that second trig identity, I could rewrite as sine A equals tan A cos A. Or I could write as cos A equals sine A tan A. Now, what the hell do I mean by I'm looking for part of that in my formula that I get given in the exam paper, and I need to substitute in what equals to then rearrange it and simplify it. Okay? Horrible questions. So I'm looking at that. I'm going, what can I replace there? Okay, so what one part of that can I replace with one of my trig identities to then allow me to simplify? And literally all you're given in this question is the word simplify. All right, so if you see a sine squared x or a cos squared x or a simplify of a tan a blah blah blah, all right, it's one of these questions. So what am I substituting in? Well, if you look at that top line, we've got a 1 minus sine squared x there. 1 minus sine squared x can also be written as cos squared x. All right, so instead of 1 minus sine squared x, I can rewrite that formula by substituting in cos squared x in that top line. In two terms which are the same divided by each other, just one. And that's the answer. 1 mark, 2 marks. That's it. That's all you're doing there. It is, without question, the worst answer question in exam. Because you're not given those trig identities. You aren't given sine squared x plus cos squared x equals 1. You aren't given tan a equals sine a over cos a. And you aren't shown how to rearrange that either. So you need to remember those two, and you need to be aware of how you can fit them in. So you're looking for something in this formula that you can switch out. It's not always really easy. It's not always apparent. All right. You'll try some of them and you'll go, this is so easy. And you'll try other ones and like, this is for them. But 2 marks. That's all that is. Any questions on trig identities? Has anyone tried any? No.
How would you know, like, this might sound like a stupid question, like, how do you know that's an identities one? Because the way that's, like, will it always look like that?
Yes.
Like, right, okay.
Because we very, very rarely use sine squared x. We very rarely use the squaring of that. That just means we're squaring cos x, but that's just another way to write it. We need to write it like that because it's the cos part that you're squaring, it's not the x term you're squaring. All right, so to avoid you squaring the x term, the right is squared behind the cos or the sine. All right, but it's essentially cos x times cos x or sine x times sine x. We don't use that in any other part of nat 5. So if it's got a sine squared x or a cos squared x, it's a trig identity question. Ugh. What have we got? 2 searchlights A and B, positioned on the ground 50 meters apart. Okay, so you've got a distance there. Right, I'll shrink that a wee bit. Hopefully you'll still read that. Okay, we've got A to B. It's 50 meters. Okay. They both focus on an object C. All right. And an angle of elevation is 43 and 36. Calculate the height, h meters of the object. This question is quite a common question. And we have to use two types of rules for triangles. All right, remember we've got rules when the triangles are right angled. Okay, and a right angled triangle is when it's got a 90-degree angle somewhere. Okay, and the rules for the right angled triangles are a squared equals b squared plus c squared. Okay, or the long side squared equals the two short sides squared. Or it's our SOHCAHTOA rules. All right. That's only the rules to be used when it's right angled triangles. Non-right angled triangles. So when none of the angles in the triangle equal 90 degrees, we've got the sine rule and the cos rule. And they are both given in formula sheet. So we need to know the right angle rules when we get given the non-right angle rules. The sine rule, A over sine A. Okay, so the small letter is the side, the capital letter is the angle, and the side relative to the angle is the one across from it. Okay, equals B over sine B equals C over sine C. Okay. Now, in this case, in this question, we've got labels A, B, and C. So that helps, all right? So that angle at C is across from the 50 meters we're given. So that would be side C. Yeah. Now remember we did a question not last week, before Easter, where the labels were slightly different. We had to change the A's and B's around, okay? But this time we don't. So that angle A, side across from it would be side A. Angle B, side across from it would be side B. All right, everyone's sort of comfortable with that labeling. All right. The cos rule is A squared, B squared, C squared, equals to BC plus A. Okay, or it gives you a rearrangement of that. So we're going to use, first, we're going to use the sine rule. Now, why am I going to use the sine rule? Let's have a wee look. In the question, so you know that's 50. Okay, 50 meters. In the question, we've got side AB, we've got this side here. Got that length. We've got two angles of the larger triangle, okay? And what that will allow us to do is find the missing angle as well. That's the first thing I'm going to do. We're going to find the missing angle in triangle ABC. Missing angle in triangle ABC is 180 minus 43 minus 36 is equal to, what's that, 79, 101. The 180 is because all three angles equal 180 degrees. All right, so 180 minus the two angles that I'm given allows me to find that missing angle. So now I've got another wee bit of information. 101 degrees. Now remember, I'm trying to find the height. I don't have enough information to allow me to do that straight away, so I'm going to continue using the larger triangle. Now what I want to do now is find another bit of information, find another bit of data. So I want to find the length AC. I want to find the length AC. I'm going to use the sine rule. A over sine A equals B over sine B equals C over sine C. Now remember, when I use the sine rule, I only need to use two parts of it. I can rule one part out. So to find that line I've made pink, that AC, that distance AC, that is across from my angle that's labelled B. I've got my angle that we've labelled C, and I've got the side across from that that's 50. I can rule that wee bit out. I can just use that and then find the missing side. All right, I'm going to find side B. Does everyone understand that step? Is everyone comfortable with that step? So if I say B over sine B equals C over sine C, B is a missing side. Sine of 36 is equal to C, which is the side we've got, over sine of 101. And to rearrange that, I'm bringing sine 36 over, it's a divide in the left, so it becomes a multiple on the right. And then I put that in my calculator, and I'll get out my length. Just 29.93. Okay, so put that in your calculator, make sure you're comfortable with what you're putting in your calculator. Okay, now what have we just found out? Found out side B. Found out side B is 29.93 meters. Now what I can do with that information is create a right angle triangle. At this time, a right angle triangle is going to involve H, which is what we're trying to find out. All right. Okay, that's a right angle triangle there. I've got the angle 43 across from H. I've got 29.93, which is across from a right angle. It's my longest side, so that's my hypotenuse. H is opposite my angle, so that's going to be my opposite. All right. So I'm going to take that understanding and I'm going to apply it to my right angle triangle rules. I'm going to apply it to SOHCAHTOA. Okay, so I've got an angle, so I can tick off S, C, and T. I've got a hypotenuse, so I can tick off my H's. And I'm looking to find the opposite. So I'm going to use SO. The other two parts of that don't apply. So I'm going to do SO. It's breaking that down as sine of the angle equals opposite over hypotenuse. Sine of 43 is equal to opposite over 29.93. Flip that round, take the opposite equal to 29.93 multiplied by my sine 43. All right, so I've missed a step there, oddness, I'm running out of space in the board. Essentially, I've taken that 29.93, it's a divide on the right hand side, so when I take it over to the other side, it becomes a multiply. All right, I've then spun the equation round, spun the formula round, okay? So that gives me the opposite side, which in this case is the height, all right, as 20.42 meters. And that is worth 5 marks. That's worth 10%. I think there's 2 questions in there worth 10% each. The standard deviation one was worth 6 marks, that was worth 20%, and that's worth 10%. So that and the standard deviation question was 22%. All right, and that's the end. And then you get 100%, you get an A, life's good.